Welcome back, everyone. I've got a Tascam 122b transport in for overhaul, and I think I've got quite a few interesting clips on this one. It's a little bit of a long video, but these are complicated and very involved, and I hope you find it interesting. I've got several hours of clips that I'm trying to compress down into a watchable video, and so I'll fast forward through much of it, but bear with me because I've got, I think, some fun stuff showing here. Maybe things I haven't shown before. I know I've done parts of a 122 and some of the C series, but I don't think I've done a complete video on any of them. So this will be a first for me on this one. So the owner packaged this up beautifully, tied the cables up, actually even did some of the cleanup of the belt debris before I got it, which is appreciated. I personally really like this series of decks. They have a very sort of a traditional, I call it a valve-like sound. If you like the sound of vinyl on valves, then you'll like this, especially at double speed. To me, at least, they have the sonic signature of a open reel, and it's just very pleasant. These are the ones that I'll choose when I'm listening to something and I just want to kick back and enjoy the music and avoid evaluating it, which I tend to do. So let's get this thing apart. Like I said, I plan to fast forward through a whole bunch of it. There's really no other way to do it because there's just a lot going on here. And any other way would get into several videos, long videos. So don't be offended by the fast forward. I'll do my best to try and narrate and describe what's going on. This deck has no PK screws going into overmolded plastic, which is cracked. These are machine screws, every single one of them, going into tapped plate. They're built to last several lifetimes, and they will if they're maintained. They're just an amazingly heavy-duty machine. Obviously, the brake pads are completely disintegrated, like they are on every one I've ever seen. Little bits and pieces of them. I'll go into more of this later in the video. I've got some replacements. At this point, I'm still looking for replacements. My former source is no more, and so I'm on the hunt for those. It looks like this lamp is burned out. Let's just test it quickly and make sure it is. Yep, no star. I get started with a disassembly. I won't bore you with bad music. As I said, these are extremely reliable decks, extremely well built, but there is a lot going on, and it all needs to function correctly in order for this to do the job it's supposed to do. So in order to make that happen, these really have to be completely disassembled, rebuilt, everything tested and brought up to spec. And I'll go through as much of that as I possibly can in as short a time period as I possibly can. Now, so far, this deck has shown every indication of very low hour use. And as I get into it more and more, I'm convinced. These also are not modular, and so everything's hardwired. And really, aside from desoldering everything individually, the way to do it is to remove the bulk of all the components, leaving them attached. And then obviously checking and making certain that all the solder joints and so forth are in good shape. But they used, before they switched over to the much thinner wires, this is a much heavy gauge wire all throughout this deck, and it's almost unseen to come across a bad joint. They're also using leaded solder on these before they switched over to the phony stuff. On the later models, I can almost count on every solder joint of the very thin gauge wire failing or close to failure. You've probably seen that in the other videos on the Mark IIs and Mark IIIs. Almost have to go through and strip and resolder every connection, every wire connection. Of course, these aren't like that, but the flip side of it is these are much more complicated and much more difficult to overhaul. Yeah, a little bit of belt debris on the inside there, or quite a bit actually. Just kind of do a cursory cleanup, get started with it. There are two washers in here, a large one and a small one. One thing I'm starting to notice getting into it now is that there's not an abundance of lubricant everywhere, which is unusual for a TIAC. I'm just trying to get most of this off so that I'm not getting it on my fingers and then finding out about it later on. But it still happens. It ends up everywhere. So the simple way to clean this one up is just to throw it in a bottle cap or something with some IPA in it and let it soak. Then come back and wipe it off. Have to desolder the lamp PCB in order to get free of those wires. And then it's just the heads, and the rest of that transport chassis is free. Keep that with the hub so it doesn't get lost. And these retainers are in there nice and tight. They're supposed to be, but oftentimes they're cracked. And these are not, so that's a good thing. Kind of try to set this up a little bit better so you can see it. You can see that little bit of white oxidation on the surface of the, I assume it's a yellow zinc coating. That will all need to get cleaned off. It's abrasive, and we don't want it on here. And copper retainers. And it looks like there's not much lube left in there, or wasn't put in to begin with, because that ball bearing should be housed in a cocoon of damping grease. Let's see what the others look like. Yep, same thing there. Well, if the third one is similar, then I'll have to say this is the first TIAC or Tascam I've seen that has not been overgreased. I don't know, that may not be a fair statement. I've seen others that were also heavily overgreased. Okay, 3 removed, 3 recovered. follower has to come off first. That's on there pretty good. Might just leave that the way it is. Yeah, that doesn't want to come off, so that's fine. We'll just be careful with it. Okay, we can take the head plate off now. Yeah, same thing there. No grease in those pockets. I mean, really at all. So you either have too much grease that has turned into glue and hardened up, or I don't know, not enough grease that just evaporated. That doesn't happen. Just doesn't have a lot of grease in this one. So it's an important thing. It isn't just used for wear and friction. It's also vibration dampening, and that's why they use damping grease on these parts. And you'll see that I replace it with copious amounts of damping grease. What's that, more belt debris or brake debris? I don't know. I think let's mount this in a vise and take it apart. Yeah, I think I'm a little out of sequence on this one. Sorry about that. There were many clips from 3 different cameras, so this is just cleaning up that capstan motor pulley rather than going after it with 45 Q-tips and spending half an hour on it. I just soak it in some IPA and wipe it off. This probably won't be the only clip that's out of sequence, so bear with me. Okay, so now on to the transport mechanism, cleaning up all the components separately. Again, this one was so clean that it was really a matter of soaking everything down, wiping it up, blowing it off, and reassembling bit by bit. I'm using this black grease here is Lubriplate 3000 for the metal to metal components, and then I'll use the regular Moly Coat, I think it's ML30, for any of the plastic parts, because of course it won't break down the plastic. the Lure Plate, both products, the Lure Plate 3000 and the Moly Coat will both be, lifetime products. That this won't have to be done again. EM30L. This is a synthetic. It won't break down the plastic, and the Lure Plate won't ever go hard, dry up, and it really won't ever need to be replaced again. Yeah, I've mentioned this before, but I like to put these E-clips with the smooth side towards the component. These are stamped, and they actually have burrs on the opposite side, and the side from which the stamping originated is smooth. So I always like to put that side towards the bearing surface. Again, no lube. I know a lot of assemblers don't necessarily lubricate every component on, every transport that happens, but I think it's important. It isn't just the introduction of lubricity into the part, but it also is corrosion resistance, and just as importantly, it's a dampening material that quiets things down. So I just treat it like it's a watch and lubricate the points of contact. Got to get the right ones on. So this goes on for quite a while. If you want to skip through it, that's fine. But I wanted to show everything that gets done for those that want to see it. Again, everything is so clean here. It's just, you know, soaking it down with a little IPA, blowing it off, and lubricating it. Nothing else needs to be done. Just more evidence of the lack of use, and I'll show even more a little bit later in the video. Okay, I've got all the oxide cleaned off the face and the tire debris off the reel pulleys. Again with the moly coat where the plastic contact pivots are. I think that one might have been stretched out from removal. So I'll grab a new one out of my kit here. I'm just dry brushing these bushings and then really the most important part is blowing them out. I'll use the Nye oil on the real bushings, bearings. Sorry, I always start coughing when I do a narration. And then on the capstan bearings, I use the Isoflex PDP 65 or 68. Looks like it's time to reorder. We'll do both bearings and then just let it sit overnight. Let that soak in. So these retainers, I just wanted to see if I could try to show that there's a small groove around the center of this. And if you look at the felt, or it's probably actually wool, spacer, whatever you want to call it, that groove is corresponding to that spacer. So the groove goes outboard. Why that is, I have no clue. What difference it could possibly make, I don't know. But I do know that engineers don't do anything that costs money for no reason. So that's the direction that goes. Again, just cleaning up bit by bit. And there's that little wool sleeve. There needs to be some end play on these, maybe 5 to 10 thousandths. Of course, they're not supposed to be tight. Move on here to the idler assembly. You'll see here in a minute, this is another clue that there's very little wear. There's no indication that this deck has ever been opened up, other than maybe the two colors of screw seal. That might be something, it might not be. But the idler tires on this they look brand new. But they're also, well, I'll show you here in just a second. I was cleaning the pulley off with a brass brush. You'll get the same Nye oil lubricant around the front part of the bearing. Again, there's so little indication of wear on this. There's no reason to even look at the motor. I'm convinced that it's fine. Okay, so 9 times out of 10, these tires would be cracked and falling off, and these are still supple, and they look fine. Felt pad's good. It's just a nylon brush cleaning nylon gears, so no damage done here. There's a little tiny bit of debris in there, but not much. I want to get a little bit of lubricant on the shaft on this, but I don't want it to be on the other side. And this lubricant does not wick, it stays in place. This gear's got a little bit more debris on it. Get it all cleaned up. Compressed air is invaluable in the shop. Now just a little bit of IPA on a brush, clean the bore, and blow it out. Now take a look at these tires. They're like brand new, other than, you know, the little indication of a little start of breakdown. The only way you kind of know that these aren't brand new is cleaning the grooves out and seeing that there is a breakdown of the oil from the rubber inside of there, and that's obvious. But other than that, it's really unapparent that these aren't brand new. And I should say that oil needs to be cleaned out, because if it's left in there, if you just swap the new tires out for the old tires, the oil that's in there will start to break down the new tires. So cleaning is not superfluous. It has a purpose. Again with the moly coat. And just a tiny bit on these pivots. So again, you look at every component on here, and nothing displays any kind of wear at all. And for a machine that was, I believe it was first produced in around 1980 or close to that, and so this one could be that old, that's saying quite a bit. Nope, that's not the one. That one. Okay, let's get this all back together. better than new. The counter assembly it's really important to have this thing operating smoothly, of course. Of course, I don't want to have any bumps or drags or anything happening on this. It's operating off the take-up pulley. And this retainer on every one of these is going to be broken, of course. It's a interference fit nylon, and as it shrinks over time, it cracks. It's still hanging on there, but eventually the inside of the other side will crack, and it will just fall off or not do its job anymore. So I'm replacing it with a phenolic turned part that I've manufactured, and it will be a lifetime solution. This won't ever have to be replaced again. I'll use just a little drop of adhesive to make sure the magnet stays put, doesn't rotate. Make sure it's coated, and then install the new keeper. Clean the groove out here, and yeah, it's dirty. Just keep cleaning it until it's not dirty. Really important, this doesn't have any sort of debris or anything like that in it. Operates freely. This one's basically brand new, so there's not much risk of any problems. I'm going to put the just the tiniest drop of dimethicone I can manage to get in the moving parts. This will tend to disperse a little bit and fill in all the voids, but doesn't attract dust. Yeah, that operates great. Just want to clean these two contacts. I'm sure they're fine, but we're here, let's clean them. Can't quite get into that second one. I'll tear the sheet in half. That won't go in there. Tear that in half. That still won't go in there. I'm going to have to cut a little sliver. That'll do it. Maybe. That'll do it. Okay, the solenoids, these need to run dry, but they also need to be clean. So really, the procedure on this, now this does have a little bit of lubricant on it, not much. It's dried out. But really the procedure on these is just to blow them out. Make sure there's no debris inside the pistons. But no lubrication. They do need to run dry. Just hit the pivot points. I'll run them back and forth a few times, and then I'll just kind of soak up any excess on those pistons. Okay, now I've already done all the work on these boards. I've recapped those two, cleaned them up, and then just reflowed anything that looked like it might need it. Put a new capacitor on the motor, and then the bonding like was done, and that now has sat and is dry. I need to get some lubrication on this front shaft bearing. And then it's the end of the day, so we'll just let that sit in that position overnight. Now what I've got you set up here to see is my new centerless balancing stand, and right this minute I'm using it to judge the concentricity of the pulley to the capstan shaft. And it takes me a minute to get this set up because, again, I'm still working with a 3D printed frame, which is less than ideal. But eventually what I do is I attach magnets to the two machinist squares, and then that helps everything stay more solid. I've got my indicator set up here. This is reading in 10 thousandths. And I'm just looking to see what kind of run out I have. It's a little bit tricky because, like I say, this is still not the final stand, and so I've got wiggle in everything, and everything is, you consider everything is rubber, everything moves. So about the lightest touch I can put on this is with this eraser, just enough to move it. And after some time of working with this, I'm finding around 3 to 4 10 thousandths eccentricity, which is pretty damn good. really. So now I'm using it as a balancing stand. And I had a friend over while I was actually getting this set up who is very experienced at balancing things like rotors, aircraft tires, propellers, things like that. And he's been doing this his whole life. And he had some interesting suggestions on this and also insight. And he liked it a lot and said that probably on one like this, what would be a good thing to start out with is to just let it rotate. Just run it through rotation several times and let it see if it can find its own heavy spot. And we did this. We played with it back and forth many times, and it actually was repeatable about 60%, 60 or 70% of the time. It was repeatable to the same spot. It would end up, if you just rotated it fast and let it go, it would end up at that same spot most of the time. And he felt like that was a pretty good indication, I do too, of where the imbalance, where it resides. So I've got a red mark on the factory balancing mark, and it's very, very close. But I find just a little tiny bit that I think I could improve it. I'll just kind of let you watch this here. It's pretty self-explanatory. That's what I'm thinking of. It. The heavy spot is right in through there somewhere. So here's where I end up taking a small amount of material, and now I wish I would have weighed that material, but I didn't think about it at the time. I should have just drilled it on top of the scale and seen how much I was actually removing. I'll do it the next time. But I've got it at the point now where any place I stop it, it stays there. And it was biasing towards where my mark is. And it was biasing there consistently, whether I rotated it or did it in quadrants. The trick is on this is to really just put the lightest amount of force I can on moving it. And this little eraser thing just happens to work well. You can see it doesn't want to return to its to where I've balanced it there. Okay, now I've got you set up on the surface grinder, or the tool and cutter grinder, I mean. And I'm working on these pinch rollers. I've shown this before in other videos, but I just thought I'd show it again. This one had a little twist to it on the other pinch roller that was sent. Basically, I get to chalk it up and remove the chalk. So I'm not taking a lot of diameter off of this at all. And I know it's difficult to see but there is a radius that's ground into the wheel, and that radius, of course, is transferred to the pinch roller. If I remember correctly, I think it's a 5-inch radius is what I measured on this on the optical comparator. I measured a brand new pinch roller and then duplicated the radius on that. Now, for those that doubt that paper towels shed fibers horribly, let me just show you what I did here. I grabbed a paper towel. I know better than this, but I grabbed a paper towel and put some IPA on it to clean the residue off. And look at this. All I did was just touch it. And now I can't get the paper towel fibers off of this. It's just incredible. So here's the other roller that he sent. And this one's obviously badly glazed. And it's so badly glazed that I can't even get chalk to adhere to it. But that's fine. I know what I'm looking for, but I just thought I'd show you this. That's a pretty badly glazed roller. And no matter what I do, I can't get chalk to stick to it. What I want to do here is just try to get it aligned so the very center of that is the center of the grinding, obviously. Just work it in a little bit at a time. You can start to see the glazing being ground away and the places where it's not. Of course, I'm sitting right above it with magnifiers, so I've got even a better view than you do. There it is, just getting it dialed a little bit more. There it is. That roller will behave just like a brand new roller for quite a while. And unfortunately, I did the same thing and grabbed the same paper towel. And then I got smarter and grabbed a microfiber. All right, so there's what it looks like, reground. Okay, now I've got you set up to measure the end play on the capstan assembly. I've got a flat tip on this indicator, and everything is attached to this vise. I've got the indicator in line, and what I'm looking for, according to the book, according to the service manual, is between 2 and 6 thousandths of end play. And when I first set this up, there was 0 end play on this. It was had nothing. The end play is important to counteract thermal expansion that happens as these are used and heat up. And so this is not something that should ever be overlooked in an overhaul. The engineers know what they're doing. They designed these things and they put these procedures in the manual, and to just, bump it back and forth and say, oh, there's some end play there, that's not really the way we should do it. I had a job come in many years ago with about, I want to say 5 pages of procedure. And that's not unusual. But the funny part about this one was in the middle of the first page, not on the top of the first page because nobody reads that, and not at the back of the first page or the back of the last page because you're already done, but in the middle of the first page, in bold caps outlined in a bright yellow rectangle, it had the words, "Do not improvise instructions." And of course I chuckled at that, but it also really hit home. Engineers do things for a reason. It's not random. And so when they tell you you need 2 to 6 thousandths on something, you need that. You can't just wiggle it. So anyway, what I decided to shoot for here was around 5. It's a little bit chilly in the shop today, not cold, but I thought 5 was a good number to shoot for. Basically what you're doing is pushing it forward and then zeroing it and then pulling it backwards or outboard and then checking your end play. Getting pretty close to 5 right there. That's kind of my target. Pretty much I've got 5. This screw back here, the thrust screw, is extremely loose. It probably just worked itself in, and I'm going to have to take care of that. But yeah, it's just, there's no resistance to it at all. It's almost like you're just turning a screw into butter. Anyway, in the end, I decided to go to 4, split the difference, and that's where I ended up. I'm just going to use some of this 3 bond and kind of fill that whole slot up so it doesn't move again. Throw some on a little sheet of paper and then just let it wick in there. Just like that. Fill the screw slot up and everything. As this dries, what I'm going to try to do next here is a split screen of the before and after lapping job of the erase head. This is one of those typical wide gap ferrite heads that is known to cause high frequency roll-off erasure on Type 1 tapes mostly. And so I've lapped this one. I looked at the repro and record heads are just like brand new under the microscope compared to he sent me a new head. I compared it to the existing head and they looked identical. So I didn't touch that other than polishing it. But I did do the erase head. And what I'm trying to show here, as well as I can, side by side, is a comparison of the two. This is post-lapping on the right and as it came off the deck on the left. And I'll link a video to kind of where I learned about this on a card here. I spent quite a bit of time researching this and coming up with a procedure, and now I have a dedicated machine to do wet lapping on these, and hopefully you can easily see the difference between the factory head and the lapped head on the right. I'm only using one grit. I'm using 1 micron grit, and the video I'll link to will detail the reasons why and so forth, but it works, and I've done it multiple times since then, and this is just something that does work. And then I also coat it with the graphene impregnated ceramic coating, and it seems to solve the problem. For how long, we'll find out, but at this point it's solved the problem. Okay, so let's get one more view here if I can. Okay, this is the original head. This is the condition of it. And from what I've seen, the ones I've looked at, this is actually pretty typical. And then there's following the lapping. So if you're interested in this, check out this other link that I'll put in a card. It was something that actually a viewer made me aware of. And then when I started researching it and testing it, I found out that he was correct, and it's a problem. So one more indication of the lack of wear on this deck are these wear marks where the bearings ride on this head plate, and the absolute lack of even having broken through the coating. This barely even marked it. I can't even feel it with a fine point. It's a good thing to kind of try and understand and deconstruct the history and the wear on something that you're working on. But this, like I said before and had demonstrated in the rest of the video, very, very little wear on this machine at all. So one more clip that's out of sequence here, but I just wanted to show that this Loctite 290 wicking grade is great for locking screws in that are already in place, and it works as well or better than the thread locker or the screw locker that's put on the head. This actually wicks into the threads and keeps them in place. And then I also use a regular blue thread locker on most of the other screws. Basically, I've thread locked every screw on here. So here is the original pinch roller, and I'm hoping that you can see the little bit of a defect that's in there, the little bit of an incursion in that rubber. And the reason why I chose to grind these previously. And again, I'm out of sequence here, but deal with it. There were a lot of clips here and many hours. And here's the other one he sent from his other deck, completely glazed over. Okay, so obviously they've been ground now. I'm lubricating them. In this case, I'm going to use this, I just call it Otari oil. It's what Overhaul foil 401D. This is a little more viscous lubricant. It's still synthetic, but on a pinch roller, I think this is a good product. And let that soak in there. Want to get a little bit on the hub, not too much. Okay. That's soaked through. I got a little bit on the roller. We'll clean that off. Not with a paper towel. Okay, of course I've got everything else cleaned up. Let's put it back together. And there's his spare. Well, not spare, it's for his other 122. Okay. Now I hate to end this video on one more out of focus clip, but this is what it is. I really thought I was focused on here, but you can see the camera chose the vise to focus on instead of the heads. But I've got these cleaned up and lapped now, and I'm going to apply this graphene ceramic coating on it. And I just wanted to show how I do that. the procedure that they recommend, and really how simple it is. The key here is to have a clean base. And so, I've just got done lapping the one, and I've just got done polishing the other and cleaning with isopropyl. And so now these are ready to accept this coating. And it's the simplest thing in the world. It's using a foam pad. They provide it with their kit, but the foam pad is just this simple. Just adding it on. Get it on the guides also. And then waiting for 30 seconds to a minute. I'll go maybe a minute or more. And then using a microfiber cloth to not to rub it off, but to kind of rub it in, is how they describe it. So I'm just taking a lens cleaning cloth, microfiber, wrapping it around this swab, and then just kind of rubbing it in, is how they describe it. And that's it. Once that's done, you let it sit for 24 hours and then polish it off with the same cloth. And I'll do this 2 to 3 times. I'll reinstall these heads in the deck, and then I'll do it again while it's in the deck. And again, watch the other video, make up your own mind on it. But to me, it works. I'm satisfied that it's a good product. So I'm thinking of offering this for sale in small quantities because it's kind of pricey. And, the giant, I'm thinking of offering it like this. The giant bottle will do, I don't know how many hundreds or thousands of heads, but, dividing it up into small bottles like this and selling it might be something people might want. So let me know if you're interested in that. So I didn't want to end the video on an out of focus image. Here's how the heads ended up actually looking. I think this is post polish, but I don't know. Anyway, thank you all for sticking with me through this, and I hope to see you again back here soon.